This is Algebra 2, Lesson 10-8, Graphs of Rational Functions. Today is Tuesday, April 21st, 4/21, 2020. Our objective today is to match an equation and its graph based on the many features of rational functions. Which features am I talking about? These ones. So horizontal asymptotes, zeros, vertical asymptotes, removable discontinuities, and y-intercepts. So horizontal asymptotes, that's where we take the limit to infinity. So as the limit as x approaches infinity, as x approaches infinity, or you want to be thinking about this as the top bottom rules. The zero is whenever the top is zero, so I'm only looking at the tops, and if something has been eliminated, I need to keep that in mind as well. So for zeros, it's really another name for x-intercepts, right? The zeros are whenever I have a zero on the top and I don't care about whatever's on the bottom. Vertical asymptotes are the reverse. If I have a fraction, I don't care about the top, I only look at the zeros on the bottom. Removable discontinuity is when I have a zero on the top and the bottom, such that they can cancel each other out. And then the y-intercept is even, I don't know, it's easier because you just set your x to 0. So I'll just say set x is equal to 0. And that's where it cuts across the y-axis. Okay, so where does this function have a horizontal asymptote for this example? It's going to be y is equal to something. Again, it's a horizontal asymptote, not a vertical asymptote. A vertical asymptote would look like that, which is x equals something. So use top-bottom rules. Look for the biggest power. Well, the biggest power in the numerator is the power of 5. Biggest power in the denominator is the power of 5. Okay, using top-bottom rules, I have the same power and same power, so I kind of ignore everything and I just look at their coefficients. -6 over 2 is the same thing as -3, and the answer here is I should have a vertical asymptote, or sorry, a horizontal asymptote at -3. Again, if the top was bigger, I can write these out for you as well. If the top is bigger than the bottom, then you go to infinity or negative infinity. If the top is smaller and the bottom is bigger, that goes to 0. And when the top and bottom are the same size, that's the magic, I can't spell, magic fraction. And that's what I did there. This is a magic fraction where you take the biggest term, the term with the highest degree, and then just look at its coefficient. What about a 0? So a 0 is whenever the 0 is on top. So I'm only looking at things that are on the top. And I noticed that x minus 1 and x minus 1, those cancel out. So at x is equal to 1, that is actually a removable discontinuity. So go ahead and cross those off. That means only x plus 3 is remaining, which means I have a 0 or an x-intercept at the coordinate x is equal to -3. Which is interesting. These are different functions, by the way, f and then g. And all of these are g of x. So they're not the same. That would be kind of weird to have a horizontal asymptote. Well, I guess it's not that weird, because it's an x and a y. Anyway, come back to the main point. So vertical asymptote, that's where the bottom is 0. Again, so the x minus 1 and x minus 1 cancel each other out. So this x plus 4 needs to be set equal to 0, and that happens at x is equal to -4. X is equal to -4. And again, the removable discontinuity is the thing that I've been crossing off this entire time. So set this x minus 1 equal to 0, and that happens at x is equal to 1. And then finally, find the y-intercept of this third function. It's different than the g of x. It's now h of x. Just set x equals 0. So if x is 0, this is gone, and I have a -36 divided by a -9. Negative divided by a negative is a positive, and I have a y-intercept at a certain coordinates, 0 comma something, right? I know that the x coordinate is 0, and that happens at, well, what's 36 divided by 9? That's 4. So 0 comma 4, or most people just say 4 on the y-axis. Okay, so I know that was really fast, but we need to connect all of the stuff that we've been learning now to the graph, the picture representation of the algebra. So let's try some. Example 1. We have, it only gives us partial information, and that's going to be the same way that it's going to be throughout all of Khan Academy. They'll somehow limit the information that you're given. They're not going to tell you every single thing. So I don't know the numerator, but I know it's some polynomial, so it's going to be something happening. Which of the following could be a possible graph of f of x? Well, let's go ahead and factor this denominator because it's not factored right now. So it's a ninja star, just a normal ninja star, because our leading coefficient is just 1. So ninja star, what adds to 6 and multiplies to 9, and that's 3 and 3. So I really have x plus 3 quantity squared in the denominator. That means I could have, I don't know what the top is, so I could have a removable discontinuity, or I could have a vertical asymptote, because this is in the denominator. So I'll list my possibilities. I could have, maybe I should do bullet points. I could either have a removable discontinuity, and this is all at x is equal to -3, right? Because you set this equal to 0 and then solve. Or I could have a VA, a vertical asymptote. That's really all I know. So what's happening over here? On the graph of, I guess it's A, but the letters got removed. So this is, I'm going to call this A, B, C, and D. In the graph of A, I have a removable discontinuity at 4, which is impossible. Why is it impossible? Because the only possible removable discontinuity is where the top and bottom cancel out, and the only thing that's in the bottom is this x plus 3 quantity squared. If there was somehow an x minus 4 in the denominator, then yeah, I can see that's a removable discontinuity, and I would assume that maybe the top function also had to have that. But it's impossible since I only have an x plus 3 in the denominator. So A is out just from looking at this. This is this point right here is not possible. I can't spell, not possible. And then this vertical asymptote at -2 also is not possible, because a vertical asymptote is where the denominator is set equal to 0. So if I had some sort of x plus 2 happening, then yes, that's a vertical asymptote, but I have an x plus 3. So again, that's not possible. Let's look at B. So B has some interesting things happening. I have a vertical asymptote at, this looks like -3 because it's between -2 and -4. So that is possible. So we can come back here and say, check, yes, that's good. I have a vertical asymptote here at x is equal to -3. The other thing that I'm noticing also is that I have a horizontal asymptote, this line right here, and we can't say anything about a horizontal asymptote. It doesn't tell us anything, because in order to determine what the horizontal asymptote is, we have to have the numerator and the denominator, or at least the highest degree, because I need to use top-bottom rules. I can't use top-bottom rules if I don't have a top. So this check mark applies to that vertical asymptote, which is good. But check it out, we have another vertical asymptote over here at +4, which is impossible. Again, for the same reason. If I have a VA here at 4, that implies that the denominator has to have some sort of x minus 4 in it. But the only thing that's in the denominator, it gave us complete information on the denominator. The denominator is just x plus 3 quantity squared. So again, right here, this VA, this vertical asymptote, is not possible. Let's analyze, so let's cross it off, right? It's not possible. Let's do C. Okay, so I have a removable discontinuity at -3, which is possible. Remember, I have a removable discontinuity or vertical asymptote at x is equal to -3, and that's good. So I'll say check mark, that's good. But again, I have a vertical asymptote at 3, which is not possible, and I feel like I'm repeating myself over and over again. If I am making too much sense, then please speed up the video. It's not possible because I need to have some sort of x minus 3 in the denominator. I only have an x plus 3. And then finally, the correct answer is D, not C, because it has a vertical asymptote at -3, and that's the only thing that we can show. We don't know whether it was a removable discontinuity or vertical asymptote. All we can say is it could, well, it has to have one or the other, I guess, but those should show up, and nothing else in terms of removable discontinuities and vertical asymptotes. Let's try another one. And again, there's like, I don't know, I'd guess like 8 different types of problems, and I'm only showing you 2, so you're going to have to take some leaps in logic for the homework. I know that makes it hard. Maybe I can try one of the homeworks with you in this video. So example number 2, okay, so now they're giving us complete information in the numerator, but nothing for the denominator. We just know it's some polynomial. So again, let's factor the numerator to figure out what's going on. So hopefully you're getting close to the point where you can ninja star these in your head. What 2 numbers multiply to -15 and add to 2? 3 and 5. 3 and -3 and +5, right? So, but just doing this out, so 2 and -15, and then the answer, as I said, was 5 and -3, which means I factored this as x plus 5 and x minus 3, and I don't know what the denominator is. I'm just going to write scribbles here. So what information do we have from this rational function, from this fractional function? So I know, because it's in the top, I know that I can either have at the coordinates, the only two coordinates that I can look at is -5, and I should say x is equal to -5, not y or anything. So at x coordinate, -5, and at x coordinate, +3. Again, you kind of just flip them or set them equal to 0 and solve. At these 2 points, one of two things can happen. Either you can have a 0, and if you don't like the 0, you can think of this as an x-intercept. I can either have a 0, or I can have a removable discontinuity. Again, we don't have information on the bottom. A removable discontinuity would happen maybe if I had an x plus 5 down here and I could cross them off, but we don't know. So we just have to assume maybe that's a possibility, which would mean it would remove that as a possible 0. But one of these two things will happen at these 2 points. So if there's any sort of 0 or removable discontinuity that happens not at these points, then that graph is out. So yet again, the letters got hidden here. This is A, B, C, and D. So at A, what's happening? I have a vertical asymptote at -3, and that could be allowed. I don't know what's happening in the denominator, so we don't know. Don't know. So that's okay. For this x is equal to -3, that's fine. But we should be seeing one of these two things happening at this point and at that point, and we're not seeing either of those things. Like, look at -5. At -5 right here, ooh, wait a sec. At -5 right here, that's a 0. It goes through this x-axis, so that's actually good. This point right here is, I totally didn't even notice it. This point right here, that's good. Check mark. That's good because it is either a 0 or a removable discontinuity. The problem is, look at this x coordinate of 3. At x is equal to 3, this point right here, I should either see a 0 or a removable discontinuity, and I see neither. So this right here, we're missing something. We'll say missing. Therefore, it's not A. What about B? Okay, so again, I'm checking the coordinates -5 and 3 to figure out what's happening. So at -5, nothing is happening, and I can immediately eliminate it. But let's analyze this a little bit more to see if we can get some more understanding. Is this removable discontinuity allowed at -4? No, this is not allowed. Why? So right here, not allowed. Because if it was a removable discontinuity, it should have shown up in the numerator. Again, going all the way back to the front side of our notes, a removable discontinuity is when I have a 0 in the top and the bottom. Well, if it's in the top and the bottom, I should have seen it in the top, which I have complete information on, and it wasn't anywhere up here in the top. So that's the reason it's not allowed. Okay, what about over here at x is equal to 3? At x is equal to 3, oh yeah, that's good. That crosses through the x-axis, so a giant check mark. That is the good thing that's happening here. In terms of this vertical asymptote that's happening at +2, yeah, we don't know anything about vertical asymptotes because that happens with the denominator, and we don't have any information on the denominator. So again, right here, we don't know. Don't know. Could be good, could be bad. We can kind of ignore it for the sake of that problem. What about part C? So again, I'm going to first check these coordinates -5 and 3. So at -5, right here, nothing is happening. So it's not C. I guess the answer must be D again. It's not C. I have to have either a 0 or a removable discontinuity at either one of these points. So, and nothing is happening here. So that's why something should have happened. What happens? Okay, so I have a vertical asymptote at -6, and that's fine. We don't know anything about the VA, so I'll again write don't know, because that's only the denominator that we're dealing with. What about at 3? At 3, oh yeah, that's good. We have a 0 or an x-intercept. That's good. And that's, oh, we actually have another VA that's not marked here. This VA at -2, again, which we can, we don't know. We don't know anything that's happening here at this vertical asymptote. But again, it's not the answer because something should be happening at this -5. Like maybe if there's a hole right here, then yeah, that would have been the answer, but it's not. Okay, so why is the answer D? Well, let's take a look at -5. At -5, that's between -4 and 6, right? Or -4 and -6. It's a 0. It has to be either a 0 removable discontinuity, and it's a 0, so check mark. And what's happening at 3? Over here at 3, oh, interesting. This is maybe a bad problem. Because at 3 we have a vertical asymptote, and it shouldn't be a vertical asymptote. It should have been either a 0 or a removable discontinuity. Oh, but, so this is not an error, because remember that you can cancel things out. So a vertical asymptote can overpower a removable discontinuity, right? So I'm thinking, what if I had something like, okay, so we know that the numerator was x plus 5 times x minus 3. That was minus 3. What if the denominator was something like x minus 3 times x minus 3? Then you'd think, oh, that's a removable discontinuity because you can cross them off. No, it actually, the vertical asymptote at -3 is more overpowering. So remember that removable discontinuities can be overpowered by either a 0 or by a vertical asymptote. They're kind of like the weakest type of what are we calling these things? Features of the rational function. So if this was the graph, then this actually is okay. It's really, really hard to analyze that and know the trick that, oh yeah, the denominator can overpower the fact that the x minus 3s were canceled out. So this is actually okay. I guess they're doing check marks. And the correct answer is indeed D. All right, so that is a hard lesson, and as promised, I'm going to try to doing one of these problems with you. So let's do I have one of these open? I do, okay. So this is a case where it's giving us the leading coefficient and actually the whole leading term, but none of the other terms. So this is a case where I can't figure out anything about the 0, the removable discontinuity, or the vertical asymptote. So what does that really leave? And I can't figure out anything about the y-intercept because I need complete information. The only thing I can say is the horizontal asymptote. That's all I can say. So the vertical asymptote, that means, let me be able to draw in Khan Academy. So I'm basically ignoring all of that. That's what essentially it's telling us there. And using top-bottom rules, taking the limit to infinity, essentially, I know that this x to the power 3 and x to the power 3 are the same degree. So if it's the same degree, that's coming back here to this one, it's a magic fraction. So magic fraction means I just take the coefficients, the horizontal asymptote happens at x is equal to, what's 15 divided by 3, that's 5. So I should have some sort of horizontal line at y is equal to 5. That's the only thing that I'm checking, and everything else is kind of ignored. So let's go through these. This one has a horizontal asymptote at 5. That's probably the answer. There's no horizontal asymptote here. The horizontal, well, I guess there is one, but it's the wrong one. Horizontal asymptote happens at -6. That's not correct. We have a horizontal asymptote here at 1, not correct. We have a horizontal asymptote here at 2, not correct. And that's the answer. That was too easy. Let's try another one. Maybe I'll just do all 4. I have time. We have complete information on the denominator. Let's go ahead and factor this thing really quickly. So we have 7, what adds a 7 and multiplies a 10, 2 and 5. So I have in the numerator, don't know. I'll leave that as a scribble. In the denominator, though, we have x plus 2. Oh my gosh, my handwriting is so bad because Khan Academy doesn't like handwriting tools. X plus 5. Which means we have either a vertical asymptote or a removable discontinuity at -2. That's a 2 and -5. All right, so in graph A, what's happening at -2? At -2, nothing is happening, so ignore that. What about B? At -2, am I doing this right? Yeah, -2, nothing is happening, so it's not B. At C, at -2, I have a vertical asymptote. Okay, so that's good. And at -5, dang it, nothing is happening. Okay, so it's not that one. It must be D by process of elimination. Let's figure out why that's the answer. At -2, vertical asymptote. At -5, again, vertical asymptote. Again, either one of those could have been a removable discontinuity, but they're both vertical asymptote. That makes my life easy. Let's try another one. So they gave us incomplete information about everything. Okay, so this is one where I can only use one fact, and that fact is the y-intercept. The y-intercept, you kind of cross off all the stuff at the beginning, anything that has an x in it, because x being plugged into 0 means all that stuff you can ignore. So in this problem, I ignore anything with an x in it because I'm going to be plugging in x is equal to 0. That is the y-intercept, and the y-intercept is, let me undo that because was that a minus sign? Yeah, it is a minus sign. So the y-intercept is going to be this 10 divided by negative 2, or the y-intercept is 0 comma negative 5. So as long as this graph goes through negative 5, then that's the answer. This y-intercept here is 3, not A. B, the y-intercept is negative 5. Okay, that one's the answer. It crossed the y-axis at negative 5. This one crosses the y-axis at 8. Nope. This one crosses the y-axis at negative 2. Nope. And yeah, correct answer, B. And our final question, I realize by giving you so many questions, you'll probably get one of these on your homework, but this one we have complete information about the numerator. So we have the quantity of x. I'm factoring this ninja star in my head. What two things multiply to 14? 2 and 7. So I have minus 7 plus 2x plus 2, which means I either have at coordinates x equals 7 and at x coordinate negative 2, I either have a removable discontinuity or I have a 0 or an x, it crosses the x-axis. So let's check both of those coordinates. That's the fast way of doing this. So at 7 and negative 2. So at 7, nothing happens, not A. At B, at 7, okay, it crosses the x-axis. That's good. Let's check negative 2. At negative 2, oh yeah, crosses the x-axis. So the answer is B. It can be either crossing the x-axis or it can be a removable discontinuity. What about C? C at 7, nothing happens. At 7, nothing happens. Okay, yep, so the correct answer is B. Done. And that completes my homework, and that also completes this lesson 10-8. I will see you guys tomorrow.